Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on random experiments. We have learned the basics of probability, permutations, and combinations. We will now look at random experiments and their outcomes. Let us get started. A random experiment is an activity that produces well-defined results. The results may not be duplicated, though, if we repeat the activity. This is what makes the experiment random. If we flip a coin, there are only two possible outcomes. If we roll a die, there are 6 possible outcomes. In either case, any result is just as likely as any other. We can know the possibility space of the activity beforehand, but we cannot know the outcome. In probability theory, sometimes we must attempt to predict the future. Suppose we were to roll 2 dice, hoping to roll an odd number. There is a possibility space of 36, but only half of those are useful for us. If a 3 and a 4 come up on the dice, that is called a favorable outcome. Remember, students, that many other combinations would have done as well. 2 and 1, 4 and 5, 6 and 3, all would have done just as well for us. They are all favorable outcomes. Let us try a simple example. If you were to roll a single die, hoping to get an odd number, what would be the probability of a favorable event occurring? Please work out your answer and the reasoning behind it.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I will bet you could guess the answer quickly. But it is important to know why probability works the way it does for when we come to trickier problems. Let us call the potential favorable outcomes A. We will also call the potential total outcomes S. We know that there are 3 odd numbers on a die. We also know that there are 6 total numbers. That means we can define A and S as 3 and 6. If the probability of a favorable outcome is 3 over 6, that is the same as saying it is 1 in 2 or 0.5. We can determine the probability of the event not occurring by subtracting our answer from the integer 1. In this case, the result is also 0.5. That was a simple example. We will now move on to a more difficult random experiment. This question is more complicated, but we will use the same basic principles to find a solution together. Let us say I have a bag that contains 6 white balls, 2 purple balls, and 10 green balls. If I draw 1 ball from the bag, what is the probability that the ball is either purple or green? We know there are a total of 18 balls in the bag. Of those, 2 of the balls are purple and 10 are green. Together, that makes 12. So, of the 18 balls in the bag, 12 are favorable choices. 12 over 18 has a common denominator of 6, which makes 2 over 3. The probability of a favorable outcome is 2 in 3. We have just enough time for one more question, students. Please get ready. I have a sack with 400 tiles in it. Each of the tiles has a number on it between 1 and 10. If I were to draw a tile out of the sack, what are the chances of drawing the number 9?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I feel like you understand how these problems work now. We can simply compare the number of favorable outcomes from the total outcomes. In this case, it is 15 over 400. When we reduce that to a ratio of 1, the probability is 0.0375. Well done. In the game of European Roulette, the wheel has 37 positions in which the ball may fall. The positions are numbered as 0 through 36. Half of the numbers are red. Half of the numbers are black. The 0 is marked as green. Students, what is the probability that the ball will come to rest on a red space? What is the probability that the ball will come to rest on a green space?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Were you able to calculate your odds in roulette? The chances of the ball coming to rest on a red position are easy to calculate. There are 18 red positions on the wheel and 37 total positions. That means that the odds of the ball coming to rest on a red position are 18 in 37, or 48.65%. The chances of the ball coming to rest on a green space are even lower. Since there is only one green space on the wheel, the chances are 1 in 37, or 2.7%. Not very good odds. That is all we have time for today. Today, we have begun to learn about the nature of random experiments and their outcomes. We have been using simple examples in order to demonstrate the principles of probability. In the next class, we will be learning about the determination of events. Until then, thank you, teacher. Thank you, students.